Here we are given in a circle AC is the diameter, right? And ED is a chord which is parallel to this diameter. Is ED is parallel, right? Now angle CBE, this is equal to 65 degrees. This angle is 65 degrees. We want what is this angle? DEC. DEC, right? When we are given this kind of problems, what we should use the properties of triangles as well as properties of triangles with respect to circles. Right, properties of triangles and properties of circles also. Let's see here we have to find about angles. In a circle, right, we have already proved that in a circle by a given r, the angle on the circumference would be equal. By any given r, whatever angle that it makes on circumference is equal and which is half of what it makes at the center. Let's take this arc EC, EDC. Let's take this arc, right? Now this arc is making this angle, and this angle, right? So this angle is equal to this angle, right? What is that? This is 65 degrees because this is 65 degrees, right? Because the arc is same. Any arc will make equal angles throughout the circumference, and that is equal to double that of the one it makes at the center. So, for example, EOC should be 2 into 65. That should be 130. But we are not bothered about that. Now this is 65 degrees. At the same time, in a semicircle, the angle is 90 degrees. That means AC makes an angle 90 degrees at E, right? What does that mean? This is 90 degrees, right? This angle is 90 degrees. Let's take this triangle ACE. ACE. If this is 90 degrees, this is 65 degrees. What does that mean? This should be 25 degrees because total is 180. 190 is gone. Remaining 90 should be shared between this angle and this angle. This is 65. So this should be 90. Right? Sorry, this should be 25. The total should be 90. 25 plus 65 is equal to 90. Right? Now AC and ED are parallel. Right? Two lines are parallel. Two lines are parallel and EC is a transversal. What does that mean? This angle should be equal to this angle. If this is 25, then this also should be equal to 25. Right? This also should be equal to 25 degrees. That's what the question is about. What is DEC? DEC is 25 degrees. Right? This is such a simple problem, very easy problem. CAD problems are verbose, but the solutions are very simple. Right? If you see here, we didn't use anything. We just used two properties, that is area in a R on the circumference is same. Sorry, any angle which is made by an arc on the circumference is same. Right, this angle, or if we make a third angle, that is also equal to 65 degrees. And then we just use two parallel lines. There is a transversal, there is a transversal. Then the angle made by the transversal, opposite interior angles, these two angles are same. That's what we have used. We use nothing else. And then sum of angles in a triangle, which is 180 degree, 180 degrees. Angle in a semicircle, which is 90 degrees. We earlier also we proved angle in a semicircle is 90 degrees because, and this is related to the similar property. Any R will make whatever angle at the center, half of it makes on the circumference. If it is 2 theta, then this is theta, right? If this arc is big enough, that means if the arc is like this, right, then this is semicircle. If this is semicircle, then this is a complete angle in the line. Angle in the line is 180 degrees, right? If this is 180 degrees, if this is 180 degrees, now the same arc makes any angle on the circumference. This should be half of 180. This is 90, right? Similarly, this is also 90. Any on any point which is opposite side of this arc should be 90 degrees. Right. Earlier also we proved this. Right, we proved why the angle is double at the center than that of on the circumference. We already proved this in a different video. Please go through that. The understanding the proof is actually very important to solve a lot of these problems. Right, not just remembering the result. We should understand the proofs. That will make us conceptually very strong, which will help us in solving a lot of problems. Right, guys. Thank you. Hope you understood this. Thank you, guys.